Okay, Bismillah ar-Rahman ar-Rahim. So it turned out that there is something wrong with the tools GTKWave or Icaraus Verilog. I don't know which one of them, but the code works perfectly on ModelSim using 10.5b here. So I created a project and added to the two files, square root of v and the test bench, and then compiled both, compile all, and there was no error whatsoever. And you can see that here I'm using the 2, I'm calculating the square root of 2, okay? And then I can actually start the simulation. Okay, start the simulation. And my simulation is in the library work because that's what I chose when I started the project. And I've chosen the test bench. So click OK here. All right. And then I'm going to display all of these signals on my wave. Control W to add them to the wave here. Right. In ModelSim, I will display hexadecimal here as well. We know that the first 3 digits are going to be the scale because I have chosen the scale to be 12-bit, which is equivalent to 3 hexadecimal digits. Okay. So now I can actually run the simulation for 100 time units. And still my ready, you can see that my ready is 0. So I can also run for another 100. And then my ready turns 1 at this point here. See, at which my D out is 16A0. 16A0 is actually 16A0 in hexadecimal. 16A0 in hexadecimal is 5,792 in decimal. So how do I convert this to the fixed point notation 500? Again, 16A0, 5792, 5792. You divide that or shift it, divide it by 2 to the 12, which is 1024 times 4, right? So you divide that again by 4 to get it the full scale. So the effect is dividing the number, which is 16A0 by 2 to the 12. And you can see that this is almost square root of 2, okay? Square root of 2. If you increase the iterations, you get a more accurate number, okay? So let us say memory add here, and then compute the square root of 2 to get the error, okay? Minus, recall. That's my error. It's in the order of 10 to the minus 4. Okay. So the error, this one here is actually in the thousandth digit after the decimal point. It's a very small error for just a few iterations, which is not more than 5 iterations. Okay. If you need more accuracy, you can actually have more iterations. Okay, let's do that quickly and see that we actually get a better estimation if we increase the number of iterations. Okay, so I'm going to say, well, let's do 10 iterations instead. Okay, 10 iterations. This is you're getting a more accurate result, but at the expense of the latency. Okay, at the expense of latency. So here you can see a question mark here in square root. Compile all. Now you have check marks on both. End simulation again. And then simulate. Start simulation. Add all the signals. Wave. Hexadecimal. And also here, hexadecimal. Then run for 100. Run for another 100. Remember that we have increased, doubled the number of iterations, so we expect that we're going to compute more. Yeah. Now you get your ready here. Okay, rather than it was about here. Yeah. Now it's still 1680, so that's probably because we need to increase the scale in order to get a more accurate result. All right, I think that's all. I will continue in the next video and show you some implementation tricks for the DE1 sock board.